Hello friends. So already I have discussed about the design consideration of the organic photodetector and how the organic photodetector is used to work. Right. So now we can design the different mainly where we can use the organic photodetector. Organic photodetector we can use in various applications. Right. In communication system, in different kind of the sensors application we can use. So based on the different wavelength we can design the different kind of the organic photodetector which can be used in different applications. Right. So today I will discuss about this thing. So based on the wavelength, you can design various kinds of the organic photodetector. Today I will discuss two different kinds of the organic photodetector. First is the visible photodetector, visible OPD. Second, I will discuss about the panchromatic OPD. Right? For that, visible organic photodetector. Visible organic photodetector means, so we will design organic photodetector for a particular visible range. Suppose UV photodetector, red light photodetector, green light photodetector. So these are the visible light, right? So the wavelength starts from 400 to 700 nanometer. This is the entire visible range, right? So this entire visible range that can be divided into three parts. Main is the UV light UV light, is the blue or green, right? Next is the orange and red. Okay, so we can design UV light photodetector for different applications, for detecting different kind of the virus, for destroying different kind of the virus, and blue and green light photodetector we can design for different applications or application, right? And orange and red light photodetector that is mainly used for visible photodetector. UV photodetector that is used for destroying any kind of the virus. Blue and green light photodetector can be used for different application, different color image sensor application we can use. Color image sensor, camera we can use, blue and green light photodetector, orange light photodetector, red light photodetector, and specifically red light photodetector that is used for visible light communication. So visual light communication that is suitable for short range communication. So if you want to send the data from one shortest location to another location, shortest location, so where in that place we can use the red light photodetector, right? So what kind of the materials are required to design such kind of the photodetector that I will discuss in this visible organic photodetector, right? So first criteria is to design the visible organic photodetector, that is band gap. Okay, band gap is mainly important parameter to design the any specific visible wavelength photodetector, right? So there is, as you know, there is a relationship between band gap and wavelength. So by using, if you want to design the UV photodetector, by putting the UV wavelength, we can calculate the band gap of the semiconductor. Accordingly, we can choose the one kind of the semiconductor, right? So for blue and green light and for red and red light, mainly the band gap is the one of the important parameter. So I will discuss some literature survey. Now, what kind of the photodetector already designed for different specific application. As you know, the last class I think I discussed about the types of the photodetector based on the structure. Okay, types of the semiconductor or semiconductor based on the structure. So there are the two semiconductors. One is the organic semiconductor and another is the polymer semiconductor. Right. So organic small molecule organic semiconductor. Small molecule organic semiconductor. Okay. That is mainly we can choose for high speed communication application. Right. So one photodetector is designed. First is the 2000, in the year of 2000, one photodetector is designed, that is small molecule based photodetector, organic semiconductor, right? That can, why we are choosing this thing? Because if you choose the small molecule, it has high degree of control of field formation. So we can design organic photodetector by using the small molecule with the help of the EVM vapor, any kind of the physical vapor deposition technique. So for that we can control the thickness, right? We can control the thickness, and the upper layer, bottom layer cannot be degraded by the upper layer because multiple layers are required. Okay. So for that, a small molecule, so one OPD is designed, right? OPD is designed that can give the 430 megahertz high speed, 430 megahertz. So nowadays, all various photodetectors were designed which achieved a high external contact efficiency, but the frequency response is one of the drawback. But this game in the year 2000, in the year 2000, 20 years back, already one water or small molecule based organic photodetector was designed, which used to give the 430 megahertz, right? 430 megahertz in the red region only, the red region, right? Apart from that, many researchers publish different kind of the papers by using this polymer molecule. Okay, so although the small molecule gives the high response, but due to some film, you cannot use, we cannot design a proper film by using the polymer. But if we use the polymer, two polymers, by using the co-mixing technique, if we use polymer, two polymers, because two semiconductors are required. One is a p-type, another is the n-type, right? So by co-mixing technique, we can design the bulk heterojunction OPD, polymer based OPD. So in this case, the fabrication is also simple, and due to the multiple interfaces, we can get the high efficiency, almost 60 to 80% efficiency we can get by using the polymer. But by using small molecule, we can only by using the 2-3 small molecule we cannot achieve this efficiency. We need a multiple layers for getting the high efficiency by using the small molecule. Okay, so one OPD is designed for by using the polymer, which can give 60 to 80% efficiency. That is for blue and green. Many research is going on still. So that is one of the example. That is one of the popular material is the P3ST and PCBM. Okay, so by using the P3ST and PCBM, mainly we can design the blue and green light. But nowadays, so by different process, different technique, we can design red light photodetector by using P3ST and PCBM also. And for designing the red light photodetector, mainly small molecule is the important. One of the popular small molecule is the CuPC, that can give high absorption peak or high response in between 600 to 800 nanometer by using the small molecule. Another material is the tin phthalocyanide. Okay. Another material is the tin phthalocyanide. So this by using tin phthalocyanide, this is also small molecule. That means by for designing the visible photodetector, we can use small molecule as well as the polymer molecule. Small molecule is one advantage and polymer material is another advantage. Both can give a high response based on their performance. Okay. So tin phthalocyanide, one tin phthalocyanide based OPD was designed that for that the gain was achieved to 10 at 1000 nanometer. That means this OPD also can use near infrared region. Okay, near infrared region. So and now in some cases one parameter is that the photomultiplication parameter. Okay, photomultiplication means we can get the efficiency more than 100%, right? So this thing can be possible by using the only polymer molecule, photomultiplication. Okay, photomultiplication only possible in a particular visible range. We can get the photomultiplication. That is efficiency, that is 50,000 efficiency can get by polymer molecule. So mainly small molecule is used for getting the high gain and the high response speed. But for getting the higher efficiency for a particular visible region, we used to prefer the small molecule. By using the photomultiplication also, we can get the more than 100% efficiency, right? So this is about the visible OPD. Now come to the next OPD is the panchromatic OPD. Panchromatic OPD. This panchromatic OPD, that means we have to design OPD which can give broad spectrum response from 400 to 800 nanometer or 1000 nanometer. UV to near infrared region, you can get the broad spectrum response. In case of the suppose visible OPD, so for UV you can get some such kind of the response. For blue red you can get such kind of the response. For red you can get such kind of the response. But for panchromatic OPD, broad spectrum response we have to get from 400 to 800 nanometer. Okay, it's a panchromatic OPD. So so if we prefer the polymer material, right? So polymer material, there are lots of polymer materials available in the market. So by using those polymer materials, we can design the panchromatic OPD. One of the example is that first example is a PDT, DDTT. So this polymer based on kind of the material by using the PCB. PCB is one of the most common material which can be used for anti-polymer material. Okay. So by using the PDDT, PDDTT and PCBM, we can get the broader spectrum response, that is from 300 to 1400 nanometer. By co-mixing only, by using the two materials and by taking co-mixing method, we can get a such broader response, which is already published, 300 to 400 nanometer. Apart from this, we can also get the broader spectral response by using the small molecule. Three different kind of the small molecule, that is phthalocyanine, the small molecule were used. Okay, so different kinds of the small molecule, phthalocyanine based small molecule were used. All are deposited on the top of the each layer, that is the stack layer. Okay, so by using the phthalocyanine material, CN based material. Okay, phthalocyanine. So this is PC. Suppose CuPC, SNPC. Okay, like these were three phthalocyanine material were used for getting the panchromatic OPD. This response up to 300 to 1100 nanometer. Okay, in both cases we can get the higher efficiency, 50 to 60% efficiency we can get. Another small molecule material, only by using the one small molecule material for panchromatic OPD also we can get. This is the polymorphin. Okay, polymorphin based on material was used that can give 50 megahertz response speed and 10% efficiency at 1100 nanometer. So only by using only one molecule, after publishing of these papers, this polymer and these three different kind of the small molecule, this research, this one material was investigated that can give 50 megahertz response speed and 10% efficiency at 11 to 1200 nanometer. Apart from this, different lots of polymers are used. Nowadays, one innovative research is going on. That research is innovation. That is by using the nanocrystal plus small molecule plus polymer. Okay, by the nanocrystal, small molecule and polymer, if we integrate all the different kind of the materials, we can get the panchromatic OPD with the high efficiency and the high response speed, right? This is the one innovative research that is going on, that is related to hybrid OPD. So sometimes only organic OPD cannot give the good results because it has some response speed problem and the stability problem, right? So if we use some nanocrystal or nanotube along with the organic organic semiconductors like polymer or small molecule, we can get the high achievement. Okay, we can get the high achievement. So one material is the lead sulfide, okay, that is mixed with the P3ST and PCBM. Okay, by using the lead sulfide, this is a one nanocrystal. This is a one nanocrystal that was mixed with the P3ST and the PCBM. Okay, so by using this kind of the material, this kind of the hybrid material, we can get the high response speed. That is already also published. They achieve the improvement. There is a improvement of the efficiency and the response speed by using this thing. So this is the one of the innovative process for designing the panchromatic OPD, right? So in upcoming days I will discuss about the wavelength selective OPD and flexible OPD. This the various kind of the OPD I will discuss on the next class.